of us have joined up, so we can now begin this presentation. So the topic today is what's new in 3Dsurvey 2.14. So we've been working on this update for quite a long time now, and today we can proudly present what is in the next release of 3Dsurvey that is due to be released to reach you guys but sometime tomorrow. So to get the update, just wait until tomorrow and then click on help, check for update, and 3Dsurvey should offer to download and install the new update for you. Okay, now let's have a look at the new features in the next version of 3Dsurvey. So first one on the list is batch processing. So what is batch processing? Now, for some projects, you no longer need to go here and click band adjustment, orientate, reconstruction in this order. You can also program 3Dsurvey to do it for you. So you just go here to project and then click on batch processing. Now, in this step, you can define which steps you want the program to take. So we can select start with bundle adjustment, select bundle adjustment mode, and set it up just like you normally would if you would set it up here. You can set all the parameters you would normally. We can go to orientation. We can actually even import the ground control points. So this will work for you if you have an RTK drone. You can import the ground control points if you use our targets. The software will try to detect them automatically and use the ground control points. Of course, for most users, I still recommend you to do the orientation step manually, because when we are importing the ground control points, it's still good to check the automatic detections that the software makes and fix them if it's necessary. But we have an option for this to be included in here already now. And then continue dense reconstruction, mesh calculation. In mesh calculation, you can define point cloud from one of the preloaded point clouds, or you can say point cloud calculated from previous step. That means input for mesh will be point cloud that was calculated by dense reconstruction. And of course, same goes for orthophoto. You preset resolution, you can say calculate orthophoto from the mesh that was pre-calculated. So this is to make the processing simpler. So we are trying to move slowly towards one-click processing. That means when you get the images, just download the images onto the computer and then set everything up, press run, let the computer run for a few hours or overnight, and then in the morning come and check the results. With the 2.15 update, this will be also improved upon slightly. In that version, we will redo the orientation. We might add some different target models that will be detected automatically for any kind of data, not just for RTK drones, but wait on that version for now. Okay. So this was update number 1. Now let's continue. New function number 2, adding points on profiles. I have here a nice point cloud. And for this point cloud, I have already calculated a few vertical cross sections. So here is cross section 1, 2, and 3. Here on the profile tab, now we have a new button hidden in here. It says add points. You can select this one, go here, for example, And we can place a point on a profile. And we can also add a name to it. I'll just leave it number 1 top. Now I'll just continue to add some more points. I will no longer name them. I'll just leave them like that. We'll put one here in the middle of the road, one at the bottom, and also here. Let's go from the same direction. 1, 2, 3. Now, I guess some of you have guessed it. If we now go to cat section, these points that we have defined here are also now our cat points. So we could use these points then to connect the break lines here. Let's make this better visible, like that. Line 1, line 2. Again, here the center of the road, and then the bottom. Now, so at this point, I have to say hi to one of our distributors who suggested this, who suggested to us that we add this function. We think it makes very nice addition to our software. In case you're wondering, this point cloud, we made a very nice 3D model of a road. So to get this model, we just flew the drone at the altitude of 3 meters above ground, and we just recorded some 30 images. If we go to cat, it will show where we recorded the images from. So we just flew the drone at slightly forward looking camera angle, and just made these photos, and we got this nice 3D model of the road from it. Okay, let's continue with our presentation. Back to our document. Now, optimized hole filling mode for mesh calculation. So let's go back here, and here I have a point cloud. Like that. We will get the only ground points. Now, if we go to mesh, calculate new regular grid mesh, we'll set the grid cell size to 1 meter. Now here we have a new hole filling mode that's called optimized. Let's see what the result will be like. I need to turn this one off. Now, before we worked with this kind of 3D terrain models mostly. Now we made a new hole filling mode, which we call optimized. So the purpose of this one is that for areas where we have like this base, we try to interpolate the data, but we try to extrapolate as little as possible. So optimized means we will try to interpolate the data, but we will try not to extrapolate it. So then we get this kind of shape when we are calculating the digital terrain model. Of course, when you are calculating digital terrain model, you still have here all option. That means you will get this kind of a result. So a nice new small feature that will be fine. Undo here. And we can go now onward to feature number 4. Improved rendering options for point clouds and surfaces. So let's talk about what we have here. So here we have two different data types. We have a triangulated mesh that we calculated from CAD data. So this is triangulated CAD data. Just for a while, I'll just go here and I'll just turn off the CAD data so that it will show better. So we want to compare this one to our regular mesh. So before you could only set one of these to show the height map. Now you can choose for each one of these the display mode. So you can say here, I want this one display with height map or without it. Also the shading, you can turn it on now for per object. So the view options are now here for each display type. So you can choose for this one to show grid, and the photogrammetric point cloud doesn't display it. The same goes for point clouds here. So we could, for example, convert this mesh to a point cloud. Just leave this at 10. Now this point cloud that I have generated in here has colors from the mesh. We can say point color, custom. For example, we will set this one to red. Now we want to see well what the difference between this red one and the photogrammetric one. We can set this one to blue. And we can now better see the difference between the old 3D model and the new one. Okay, so this was feature number 5. Now, feature number 6, we started adding support for point classes to 3Dsurvey. So in here we have a point cloud. Now, when you do the classification, go to next step here. Select the ground as usual. Next. I see a little bit of terrain is missing here. I can try clicking recalculate it once again. That should improve the 3D model. of the ground. Like that. Finish. I guess I have again too many projects opened. I'm getting to filling up my memory. It still works. So now when I finish the classification, what happens now is the points get split into different classes. So we can now turn off this unassigned class. So unassigned class means everything but the ground. So we have just turned off the ground and just left the ground selected. Okay, and we have the ground points only. We can turn the ground points only. So now we have no points, we only have some cat data, which I will turn off now. And we can choose now here what we want to display. So we can display the above ground points or ground points. So this is for starters. We also plan on improving this classification to also classify the points on buildings, high vegetation, low vegetation, and this kind of classes. And also 3Dsurvey now supports reading class formats. So if you import a point cloud from LAS, from LiDAR that is classified, it will read those classes and it will list them here. So you'll be able to then select the classes here. Also, now after you do the classification, when you go to mesh, calculate new regular grid mesh, here you can now choose, I think you saw that one earlier. So you can choose which classes you want to calculate the new mesh from. And we will get now again to the same result we got earlier. So here we have the point cloud. If we turn off the point cloud, we see mesh only. Nice, right? Okay. Now, another small upgrade, but I think a useful one, is we added ability to reorder elements in our lists. So let me show you why this is helpful. So here I have a project with 4 orthophotos. And 2 orthophotos overlap here. Let's turn that one off. So you see here we have, so this is an actual project we did. We flew to a few kilometers of the road with the drone and we made orthophotos. Now we want to join this data. So what we can do now, we can change the order of the orthophotos. So the one at the bottom will be the one that will be shown at the top, will be shown over. So here we see now this orthophoto is the orthophoto number 4 is displayed over orthophoto number 5. And we can rearrange this to make them show what we need. Why is this one helpful? Well, it will also allow us to better design. So when we go to export, we can then select which area. We can now cut our entire results into, for example, smaller areas. Like we can select this one and say, let's wait just a second. The first one, we just want to export this part of orthophoto. Let's wait maybe a few seconds, and I should probably close some other projects that I have opened. Like that, we can define and then say, okay, increase the maximum Y. We want this area into single orthophoto, and that way you can then join the orthophotos into leaves. You can say, okay, here we will have the first one, and you will export this part, and then you can select here and say, okay, this will be my second one. And you can also enter round numbers here. For example, you can say, okay, to 700, and this one will round slightly up, like that. And you can define the exports like that. If we combine this function then with cut tool, so we go here to merge, press next here. While this one is preparing, I'll just close one of the previous windows. And let's close also this one. We don't need either. Let's just wait a minute for this one to complete. Okay, and here in this step, we can now say, I just want to keep, select merge area. We can just say, from this orthophoto, we will use this part here. Let's say like that, to the row. We can select wherever we want, like that. Paste selected. Just wait a while. Now what will happen is we only get this part of orthophoto selected. Let's press finish. Merge selection. And press finish. And now we can join this orthophoto with that one, and we will get a nicer border here. Okay. Let's go back to our file. We have now here a next function, selection with guidelines for point clouds and meshes. So let me show you exactly why we use this function for. So here we have a point cloud of an actual example where we were calculating volumes. So here for this example, we got some additional data. So we took measurements. We made point clouds from the images. Now, after we did everything, the construction guys, they said, okay, for this area, we still need to excavate additional few meters. We need to lower points here to the altitude of 291.56. So they said we need to lower these points here. So what you can do now, you can go to point cloud, and here on select, you have option select from cat. So here you can select. Now that means it will select the points that are within the boundary that is defined by this layer. Press calculate. So that has selected the points inside of this green square. If we go to top down and ortho mode, we see that these are the points that are now selected. Then we can go to cat. These points should be at 295.81. We can go here, manipulate points, set height 295.81, enter, turn off top down and ortho, and we have just lowered these points to this altitude. And we can repeat the same thing for these points inside of the blue line. So they should be lowered to altitude 292.8. Go to point cloud, select from cat, to 292.8, calculate. So it has automatically selected the points inside of this rectangle. Manipulate points, set height to, like that. You should avoid making the same mistake I just did. So because these points were selected, it just adds the points to the selection. So what I did now, I also moved the points in here. So these ones we should move back. So we'll just use this select, move this away. So the green one should go to 295.81. That is set. Like that. Remember, after you move them, press clear here so that you clear the selection. And you can then continue doing that. And the same thing also goes for the mesh. So here I already have the mesh calculated. You can also select points on mesh. For example, select from cat, you can select this one and then use manipulate points to move these points as well. So instead of set height, you could just use increase height and then write minus half a meter, for example. That means it just lower these points by half a meter. Okay. Now, really last but not least, so let's go here to our image tab. So now what we have to do, we have to reopen one of the projects that we previously closed, or we can use this one, for example. So here we have the name. So the images here are now sorted by our image name. So here for some debugging, we can now reorder these images by pixels. So we can check, for example, the average error on image, and we can see we can order images based on the based on number of 3D points they see, or based on angular error. That means the difference between the angle in here in our telemetry and the angle that is calculated after bundle adjustment or orientation. Or 3D error. So here we didn't use so here we had the ellipsoidal height. So because of that, and we had the phantom drone. So all the altitudes are about 70 meters off, but this is okay. Or based on any other data type. So usually this one will be useful for ordering images by pixel errors. And we can see if our reprojection error here, if our mean reprojection error will be high, we can order images by our error, and we can check and maybe deselect that image and retry to do bundle adjustment without that one. Okay. Other than that, we also have some small new functions. One of most useful updates with this version is new project file format. So now, from now on, when you go to project, save as, 3Dsurvey will default save into 3DP file format. This one is useful because we upgraded how the memory consumption that we have when we are saving the project. So before, if you had a very big project and you tried to save it, sometimes it happened that saving failed because we ran out of memory. Now saving a project into this new project file format requires no additional memory. So now when it's saving, the memory consumption is not going up. Also, the saving process is now slightly faster. The difference is from now on, the new file formats are called 3DP. That means if you will save a project in version 2.14, you will get this file. That means only the version 2.14 and above will be able to open them. Of course, you will be still able to open the old projects, which are these ones. Now, another small new function is ability to calculate normals from LiDAR data. So let's go here. Project open. Just 1 second. I have here a project from the new L1 camera. So these points, they don't have the, so when we calculate a point cloud out of images, point clouds also get normal information. Now these points, they lack normals. So out of these points, you wouldn't be able to create a textured 3D model. So to go around this issue, we added a new algorithm. So you can right click onto point cloud and you can press here, calculate normals. So it would take a few minutes to calculate them on these 39 million points. What we will do first, we will just reduce point cloud and we'll just calculate for the purpose of this demonstration, point cloud with 300,000 points. And now on this one, we can go to calculate normals. Yes, let's calculate. Like that. Now if we turn on shading, we will see different shading because we have now normals for this point cloud. And we could then make a new 3D mesh out of this data. But we won't do that right now. So then a few more small functions. So from now on, 3Dsurvey will always default to hybrid bundle adjustment mode. So when we go to bundle adjustment, here it will now always default to this one. If you're used to using global, you have to click manual now for global. And we added support for iPhone 12 images. So iPhone 12 images were slightly different. We had to add some support into 3Dsurvey so that we were able to read those JPEGs. And last but not least, we added a new laser scanner data format, which is called PTS. Now here under point cloud load, there is also a PTS file format. So that will help you read those data in if you have that kind of scanner that makes this format data. So these were the new functions that are coming with tomorrow's update. Now let's check if we have any questions. So I see that Mateusz has asked a question. He's asking, is classification also automatic before orthophoto? Not yet. We plan to add automatic classification when we upgrade the classification algorithm. Hopefully this will be done with the 2.15 update, so that's the one that's coming next after this one. So maybe about 3 months from now. Question number 2, is it possible to display the DSM or mesh in slope color because it's easier to visualize and draw slope breaks? Constance is asking this question. Unfortunately, not yet, but we might add this support. I think this is a good suggestion. So just like we added points here on vertical cross sections, if we have, maybe we can also add support here on mesh to add slope-based coloring. So I know what you mean. Like here you have display height map, and we want shading. So instead of height map, you would want the height map to display the slope. So where we have very steep terrain, we would get, for example, red color mesh, and where the terrain is flat, you would get blue color mesh, for example, or maybe some other height map data like that. Well, I think that's a good suggestion. We'll see if we can fit this one in one of the future updates. Question number 3, is it possible to create automatic break line from mesh? Not yet. So Matteo Crozzi is asking this, not yet, but it's also one of the features on our feature list. So this one is already on the list, automatic break line extraction from mesh. So we want to add that one in the near future to 3Dsurvey. Okay, I think these were all the questions we had today. I'd like to thank all of you for attending this webinar and see you in the next one. Bye-bye.